In this video, I'm going to show you how to create a fracture simulation in Houdini 16. I have my geometry ready here, so let's begin the tutorial. First, we're going to go into our scene here and we're going to jump into our geometry node. And inside we will see our file, the geometry, and we are going to create a few nodes to set up this simulation first. So by pressing tab, we're going to type scatter and we're going to create this node. We're going to connect our obj file or geometry file to our scatter node, and we're going to press this blue icon here to display the current look of our project file, our geometry, and we'll see this is what we get. Our geometry in a scatter form. And for this thing, the reason why we create this is we're gonna use this scatter to represent the fracture point that we're gonna create right now. So press tab again and we're gonna create a Voronoi fracture. And we are going to connect our geometry to the first input of this node, and we're going to connect our scatter to the second one. And if we turn on the display, we should get our fracture point based on the scatter node. We're gonna have to wait for it to calculate the fracture point. It might take some times, depends on our setting. So we're gonna go back into the so we already done that. So as you can see here, we have all this fracture point. It was created based on the scatter node that we create earlier. So, and if you go to the scatter setting, you see the force total count is by default is 1000, and the more number we set up here, the more fracture point that we will get in here. So for this tutorial, I'm just gonna lower it down to 250 so that we can have a faster calculating time, and this is just an example of it. So yeah, now we can see that we have a slightly less fracture point. So from here, we're going to create another node called rest position, and that is where we end our setup. Okay, now everything is all set. We're going to create a fracture simulation using rigid bodies. So we're going to go on the rigid body shelf here, and we're going to create a new RBD fracture object. So clicking this will pop out a new window, and we're going to create a RBD pack object for this tutorial. And if we have like a simulation that interact with the fracture, the RBD fracture object is required. So we're just going to create the first one here, and we're going to select our geometry and press enter to accept. By default, Houdini will help create for us a Autodoc network, and if we jump inside, we'll see that everything is already set for us. We have the RBD pack object here based on our geometry, and we have our rigid body solver and gravity and so on. And as you can see, I already set my geometry to place slightly a bit higher because we need the velocity for the geometry to actually move and fall and create those fracture. And if we press play, as you can see now, when it reached to the grid point here, we didn't get anything. That is because there is no grid or like a plane for the object to interact, so it won't be able to create any fracture. And to do that, we're gonna create our own ground plane here. So first we're gonna press tab again, and we're gonna type for ground plane, and we're also gonna create a new static solver, this one. And now we're gonna connect the ground plane to the static solver. And as you can see earlier, we already have this one on the right side here, and we just create the one on the left side here. Now we have to merge both of these things together. So we're gonna press tab again, and we're gonna create a new merge node. And now we connect our static solver to the merge as well as the gravity, and the merge will now connect to the output instead of the gravity. And there we go, we have our grid object here. If we go to the ground plane, you can untick this to if you don't want the grid to be displayed. So yeah, we can even play with the setting here to set the size for the grid if you don't want it too big or something. There we go. And now if we press play, we should be able to get our fracture simulation. So if we play again, we should get something like this. There we go. There. And as you can see, the fracture will move along the ground plane as well. And we can also play with the setting on that part. If we go back to the ground plane, go for the physical tab, we can play around with the bounce setting and the friction. We can set up our own preferences for that. There you go. And now we already have our fracture simulation done. But for this tutorial, I'm also going to teach you how to add a little bit more details on that fracture. So we're going to create a debris that actually bounce out, or a particles that actually create when the fracture is happening. So as you can see, this part we already have the fracture. So what we want to do is we're going to go back to the rigid body shelf in here, and we'll see the debris setting here. We're going to select that. We're going to select our geometry, and we're going to press enter. And Houdini will create for us a new debris sim. If we press L, it will arrange the knot properly, and in here we will see all these knots, and we have the pop source. This is where our SOP, that is as you connect back to our geometry, which is the OBJ, and we have our pop object here that we can play around with the physical things like bounce and friction, same as the ground plane, but this time is is the debris itself. For now, we're just going to play around with the pop source and mostly with the under the birth tab here. Just play around with these 4 things. And if we press play now, we will get something like this, and we'll see the particle will come out from the fracture point to represent the debris. But right now there is way too much particle. As you can see in the constant birth rate, that is like 5,000 here. So what we're gonna do here, I'm just gonna lower this one down to just 10, as this is a hummingbird. So I'm just gonna, we all know this bird is like a very small, very small bird. So, and we're gonna put our constant activation to 0, and we're gonna add a bit of number here on the impulse count. I'm just gonna put 10. Impulse count is actually the number of particles that will emit from the fracture as it's interact with the ground plane. So yeah, there we go, and press play, and we should have slightly less particle. We already have the fracture interact with the ground plane, but apparently our debris does not interact with the ground plane. That is because we're gonna have to create another ground plane for the debris sim as well. We can go back and create like the one that I already taught earlier, or we can just go back into our Autodoc network. We can copy this one by pressing Ctrl C, go back into our debris sim here and press Ctrl V. And now we're gonna create another merge, and we're gonna connect these 2 things together again. So if we press play, we will get the result. And you can see that very nicely done. Okay, now as we already complete the debris and also the simulation, I'm also gonna teach you as well in this tutorial how to create a impact smoke. And for this part, we are going to go to the pyro effects, and we're gonna create a wispy smoke. We're gonna select our debris source here, and we're gonna press Ctrl and select our wispy smoke, and it will create for us this volume box. And also inside the debris sim, you will see there is a new part that Houdini already helped create for us. I'm gonna play around with this thing. If we press play now, we will get the basic smoke that is already set up for us. And maybe we like it or maybe we don't, so we can play around with the setting. That's what we're gonna do right now. And as you can see in the debris sim here, we have the source volume, which is the debris that we already selected earlier, that create by the fracture point. And we have the pyro, is where the smoke was created here. I think so. And we have this pyro solver. This is where we're gonna play around with it. And we'll see the time scale. This is to turn on and off the smoke. And we have the temperature diffusion to control the temperature, but we're not gonna play with that, as this one is if you are creating like a like a hot, like a heaty smoke or something, we are just going to go into the shape tab and we're going to play around with this dissipation. And dissipation is actually the number, like a disappearance of the smoke over time. And the higher the number, the faster the smoke will disappear. So we're just gonna play around with this. I think I'm gonna set up. I'm just gonna try 0.65 right now. As you can see, the smoke will slowly disappear over time. This is what the dissipation setting control. So the higher the number, like I said earlier, the higher the number, the faster the smoke will like go away. So if we, for example, if we put 1, you should have it go away faster. And or maybe we try 3 or something. The point is, whatever it is, the number that you want, it's based on your preferences. And as you can see, there you go, just come and go. And that's pretty much it for this tutorial. But then I'm not going to end it right now, as we need to see what did we achieve from the result, something. And just going to go to the render view for a while, and if we press render, this is what our end result will be. We can't see where is the fracture, because right now, as you can see, this all this sphere, and the sphere is actually representing the debris, and it's right now it's way too big. It's even bigger than the fracture point that we already created earlier. So how do we fix this? Because we don't want it to be rendered out the final output, or even just a test render as like this kind of shape. It looks annoying. So what we're gonna do now is that we're gonna jump into the debris sim here, and we'll see this dot import. And there are a few ways that we can create this. The first one is the much more straightforward way, is we can, by pressing tab, we can create a new point node, and we're going to connect these two things together. Go to the setting and change the attribute to scale, and we're going to change the vex expression here into constant value, and we're going to play around with this number here. And for example, if we create 0.1, it will affect the size of the debris. So this basically right now is just a try and error. If we want to just see this part of the render, just press shift and create a box here, and it will just render the part with the box, the part inside the box. Oh yeah, no wonder we didn't see the result. I didn't turn on the display here. Okay, we should be getting like the result now, or at least that's what I hope so. It should be. Is it still too big? Maybe it's, oh yeah, there you go. Apparently 0.05 is still too big. And right now it's okay, but because we just want the debris to be like a just like a tiny detail, so I'm just gonna add the 0.0 here. There we go. I think this one should be okay, I guess. 0.7. Yeah, okay. So basically the point is that is one way how to fix this. Another way is we can create a platonic solid, and we're just gonna disconnect this one. There we go. And we're gonna create a copy point, stamp here, and we're gonna replace these two thing together. And if we go back to the platonic setting here, we have this thing, and we can play around with the solid type whatever we want here to represent the debris, for example here. And but if we select here, it's like, whoa, it's way too big representing the debris. And what we need to do is we're gonna go here and play around with the size here. We can even create a transform node, and play with the scale here. So as you can see, there it is. So the debris will be in a much more smaller scale. And if we render this one now, we will get a better result. So yeah, so there is two ways how we can fix the debris. So that's all from me in this tutorial. I hope it helps. Thank you for watching. Bye bye.